Identify and label the Bronsted-Lowry acid, its conjugate base, and then the Bronsted-Lowry base and its conjugate acid in each of the following equations. And then we have this equation right here. So we have to find out the four components, the Bronsted-Lowry acid, the conjugate base, the Bronsted-Lowry base, and the conjugate acid in H2PO4- plus HCl, which will yield H3PO4 plus Cl-. Now the easiest way to go about this is to first pick your pairs. I just like to start from left to right, so I will always highlight the most left ion first. In this case is H2PO4. And I say, okay, which component on the product side, on the right side, is a pair to this? They have to look very, very, very similar, and they have to have the same elements. So phosphorus goes with phosphorus. So H3PO4 would be the pair to the H2PO4-. Now, just see. Your other pair should make sense as well. HCl, okay, I have an H and a chlorine, and then here's the other chlorine, so they have to go together. Okay, cool. The next thing to do is get rid of this conjugate word. Conjugates just means basically the other part of the pair that's being produced. And if they're always being produced, conjugates are always on the product side. So H3PO4 would be a conjugate something. I just don't know at the moment whether it's the conjugate acid or base, but I know it's a conjugate. And the same thing with the chlorine. On the flip side, the actual acid and base, aka the Bronsted-Lowry acid and base, those are the two acids, the acid and base that you're reacting. Those are always going to be on the left side. So H2PO4- has to be a Bronsted-Lowry, I'll just label it as Bl, something, and then HCl has to be a Bronsted-Lowry something. But now we're going to figure out which one is actually the acid and which one is actually the base. This is when you analyze the pairs. Pick a pair, doesn't matter. Let's go with the green, you got it. H2PO4- with H3PO4. Now, remember guys, acids always have one more hydrogen, one more hydronium, right? Hydronium H+, then their conjugate bases. And then on the flip side, the bases always have one less. So the idea here is that acids out of a pair always has one more hydrogen. So look at those hydrogens. H2PO4-, I have 2 hydrogens. H3PO4, I have 3 hydrogens out of the pair. Acids will always have one more. I like to think of it in terms of acids and not really bases. I like to have the increase in number. So the more hydrogens, you're the acid. So out of these, H2 versus H3, H3PO4 would be the acid. It's got one more hydrogen. And then that means that this has to be the base. It's got one less. Now you do the same thing for the other pair. HCl, this one has a hydrogen. This one has no hydrogen at all, the Cl-. So out of these, this one has to be the acid. And then likewise, this has to be the base. And if you notice, guys, on either side, you have one acid and you have one base. So if you come up with a scenario in which you have 2 acids on one side or 2 bases on one side, just pause, go back, try it again. You're only allowed to have 1 acid and 1 base on one side of the equation. All right, but this is the answer right here. Hopefully this helped. Let me know in the comments. Thank you so much for viewing the video. I hope I'm giving you good educational content out there and that this is, easy to follow. But just let me know. Just, let's get the word back to me that I'm doing my job right here. Thank you, and I will talk to you in later lessons. Have an awesome day. Bye-bye.